Alright guys, today we're going to be doing the part 2 of linear functions. In the previous video we talked about finding the slope and the y-intercept and then graphing it, and then also finding specific values from an equation, okay? So let's see what we're going to be doing today. So today we're going to be looking at the parallel and perpendicular slopes and the equations. And they're also going to be finding x and y intercepts from an equation. So let's start off with the parallel and perpendicular slopes. So first, you have a parallel, right? So parallel. First, you know what the difference between a parallel and the original equation is. So parallel slope. So parallel slope is going to be the same, but my y-intercept is going to be different. And it can be any y-intercept. So, different. Alright. So, let's take an example. Let's take a look at an example here. So, let me clear this. Alright. Now, let's take a look at that first example I have here. We're going to take a look at y equal to 3x plus 5. This is going to be our original equation. So, I'm going to plot this. So last time I showed you how to plot it. So I'll go out 5 on the y-axis. 1, 2, 3, 4, 5. Right there. Okay. Then I'm going to go 3 up and 1 to the right. So about there. 3 down, 1 to the left. And I'll do one more. 1, 2, 3. And then 1. No, that's not what I needed to do. So that means I'll be going 1, 2, 3. And then 1 here. Okay? Am I right? Yeah. 1, 2, 3. Yeah. 1, 2, 3, 1 to the left. Alright? So now let me graph the line here. Graph this line. Oh no, that's the wrong type of line I needed. I need to have the one with the arrow. Yeah, that's the correct one. Let me adjust it so it goes through all of the points. And let me fix this. That should be like right there. That right there. Point right there. And a point right there. Okay, so there we graphed the original equation. Okay, now let's take a look about how to graph the parallel, right? So now, the parallel, as I said, same slope, so y equals 3x, but the y-intercept is different. So I'm going to say b plus b, because b can be anything, but b can be anything, cannot be equal to 5. Because if b is 5, then, and if I were to graph the so-called parallel equation, it would be overlapping the same line. So we don't want it to overlap. We want it to be parallel, right? So b cannot be equal to 5. So just keep that in mind. Then, so let's say, let's do our y-intercept as a 1, right? If I do my y-intercept as 1, right? I'm going to graph the same slope. 1, 2, 3, 1. 1, 2, 3, 1. Okay? So there, let me graph that line for you. And it'll probably look parallel to that line. It kind of looks parallel. I mean, yeah, it's parallel to that. Okay? Fix that a bit to make it look a bit. Yep, that's the one. Okay? Alright, so that's how you would graph the parallel. Because if you all you need to remember is that it has same slope, but a different y-intercept. And that y-intercept cannot be equal to the same y-intercept as the original equation. Okay? So this, I'm going to write it here, that this was for parallel. Now let's take a look at the perpendicular. Perpendicular, you know that a perpendicular crosses to make a right angle, right? It will be like this. And then it can be like that. And then, you know, it makes a 90-degree angle, right? So you know what a perpendicular line is. So we know how it should look like on the graph. So perpendicular have the negative, oh no, I know what that are. Negative reciprocal of the original slope. But the y-intercept can be same, right? The y-intercept can be same. Y-intercept can be same, right? So that means even I can have the same y-intercept as from the original equation, and the lines won't be overlapping because I have a different slope. Alright? Alright, so now let's take a look at an example. I'm going to do the same exact example I did for the parallel line, but we're going to be doing it for perpendicular. So the equation was, I think it was 3x, y equal to 3x plus 5. So first I'm going to graph the original equation. So 5 comes right about there, 3, 1 to the right, then 1, 2, 3 down, right there, okay? And then I will quickly graph this. I think it kind of goes, make it look, yeah. Alright, that's better. Okay, so I graphed this equation. This is the original one. And make it not confuse, alright. O for original. Then the next one is going to be perpendicular. As I said before, perpendicular has negative reciprocal. So that means the slope will be negative 1/3. Because the reciprocal of 3 is 1/3, right? Because look, 3, 1 equal to 1/3. The reciprocal means you're flipping the numerator and the denominator. If I were to do that, then it becomes 1/3. Then I also add the negative because it's negative reciprocal, right? If you had a negative slope, then you would do, so say if I had negative 3, this is not part of the example, but I'm going to show you what happens. If I had negative 3 is my slope, right? Then it's going to be negative of negative 1/3. And then these two negatives cancel out and you get positive. So if it's a negative, the slope of the perpendicular line will be positive because of the two negatives that cancel out. Alright, now let's continue. So we got our slope, so negative 1/3 x plus 5. I'm going to do the same. So let me do it in a blue color. So we have the same y-intercept and then negative 1/3. So I'm going to go down 1. I'm going to go down left to the 1, right to right 3. So 1, 2, 3, about right there. Let me do the same here. So go up 1, left 3. So this will be around right somewhere about there. And then I'll graph the line. Okay. Let me fix it so it goes through all the points. That's about it. So there we go. It creates that 90-degree angle right there. Okay, so that's how the perpendicular lines are supposed to look. Okay? Okay, I think we got that. Now let's now we've figured out how to graph parallel and perpendicular lines, right? I'm gonna go like over a summary. So parallel lines have the same slope, but a different y-intercept, and that y-intercept cannot be the same as the y-intercept in the previous or the original equation. Okay? And then for perpendicular, the slope is going to be the negative reciprocal of the original slope in the original equation, but the y-intercept can be the same. Okay? So now let's put a check mark that we finished that. Now let's go into the next part, which is finding the x and y intercepts from the equation. Okay? So let's take a look here. Alright. So from how to find it, right? So you'll be given an equation. Let's say y equals to 2x plus 3. And you need to find a y-intercept and x-intercept. So y-intercept we already know is 3. But in order to find y-intercept, you need to make sure, to find the intercepts, you need to make one variable 0. So say, for example, asking to find x-intercept, right? So if I had the equation, they're only going to give you it in standard form, which is the ax plus b equal to c. But I will give you that in another, give you more depth into that in another video. So let's say I'll give you 15x plus 5y equal to 45. Now, in order to find it, right, that means in order to find y, I have to make x 0. So that means if I make x 0, I do 15 times 0 plus 5y equal to 45. 15 times 0 is 0, so I just get 5y equal to 45. Then I divide both sides by 5 to isolate the variable y. Then 5 and 5 cancels out. Y is going to be equal to 9. So I figured out y is 9. Now, I'm going to do the opposite. In order to find x, I'm going to make y as 0. So if I make that y as 0, that means I get 15x plus 5 times 0 equal to 45. Then 5 times 0 is 0, so I just get 15x equal to 45. Divide by 15 on both the sides to isolate the variable x. Then I get x equal to 3. Okay, so we found the x-intercept is 3 and the y-intercept is 9. So that's how you would find the x and y-intercept. You just need to make each value 0 one at a time, and you can solve for it. And it turns it into a one variable equation. Okay, so that concludes our video for today. Hopefully all this material made sense to you, and please make sure to subscribe and leave a like. Thank you.